Thank you so much to all of the organizers of this conference for making this happen in this very difficult year. Also, thank you for all of you listeners for attending this. I know that sitting in front of a computer for additional time these days can be really difficult. I'm here today, though, to tell you about a system that we're really excited about. This is a system that we've been developing for the portable detection of harmful algal bloom toxins. My name is Sarah Bickman, and I work at Diagnostics. First of all, for those of you who have heard similar things before and are thinking that this sounds familiar, I wanted to let you know that LightDeck is actually the new name of MBio Diagnostics. We're the same company with the same mission, vision, values, all of those different things, but we do have a new name. At LightDeck, we believe that diagnostics really requires both speed and performance. We feel like the problem is that laboratory testing is just too slow to provide the rapid answers that are needed in today's world. Rapid testing, though, often gives results that are just inadequate for those needs. At LightDeck, we've tried to combine the advantages of giving laboratory quality results in a very rapid platform. The idea here is that you should be able to get these high quality results in the matter of minutes, anywhere, anytime. This is all based on our waveguide-based platform. We call it LightDeck, and we feel like it has a number of advantages. As I've mentioned before, this provides laboratory quality results. Secondly, it can provide very rapid results. Some of our assays are as short as 5 minutes. The one that we're talking about today, though, is 10 minutes. The workflow is designed to be very simple. The idea there is that you should be able to take your sample, add it to the cartridge, insert it into the reader, and then walk away. We feel like that simplicity is really key for providing high quality results because it doesn't require a user to be there at the right time or to interpret the results. We've worked hard on keeping everything low cost. We know that it is very difficult to stretch budgets, and so we've worked hard to use commercially available components in new ways to keep costs down. Finally, we feel like another major advantage of our system is that it's easy to multiplex. We've done tests with up to 57 different tests on a single cartridge. In this application, we feel like that's not actually necessary, but we're very, very good at detecting 2 to about 10 different things at once. And for the toxin testing space, we feel like that's very important. The question that we really want to answer is, if you have a nasty looking algal bloom like this, is it actually producing toxin or not? We feel like that direct toxin detection is very important for a number of different applications. As you know, this could be used for ecosystem monitoring, source water management, managing recreational waters, or of course, making decisions about treatments. So our current test is to detect microcystin and cylindrospermopsins. You can get results in as little as 10 minutes. The workflow is simple. You scoop a bit of water out of whatever water body you're monitoring, do a very simple sample preparation step, and insert that into the cartridge. Once you put the cartridge into the reader, which is the blue box that's shown on the bottom left here, then the computer that's attached to it will control all of the functions of that test. So you don't have to be there 10 minutes later to get out the results. The results are digitally interpreted and they're available whether you come back 10 minutes or 10 hours later. Currently, as I mentioned, we've got a microcystin and cylindrospermopsin test. It's got simultaneous detection of microcystins and cylindrospermopsins. Nodularians are also measured along with microcystins. It's got a 10-minute one-step workflow that's very simple. And for those of you who are familiar with our platform, we are using a Gen 2 test now, which has improved congener coverage. The reader that's shown on the right here is our LightDeck Mini. We're in the process of rebranding it. It's a low-cost, rugged USB device. It's connected to a laptop. The idea there is that there's proprietary software that comes with your reader. Using that software, you can get quantitative digital results, so there's no ambiguity in your results. This is how it really works. On the left side is our cartridge sort of taken apart into 2 pieces. As you can see on the left side, that black piece is what we call an upper, and it's basically used to contain fluid within the channel. All of the magic happens on the lower piece. This is our waveguide. And what we do is we print a bunch of different biological spots on the inside of that waveguide. That's where all of the different assays and the actual detection happens. On the right side of the screen, you can see that cartridge in a cross-sectional view. So you add your sample to an inlet port, it goes down this capillary channel, and in doing so, it activates all of the assays. When you put the cartridge inside of the reader, a laser turns on, and this is used to illuminate the biological assays, and we do fluorescence detection to read that out on a camera down below. In terms of the assays, these are all competitive immunoassays. So for example, for microcystins and cylindrospermopsins, the way they work is that we print toxin on the surface of that waveguide. Then when you prepare your sample, it is being combined with an antibody. This antibody comes into the channel along with your sample. If there's toxin present, your antibody will bind to the toxin and you get a dark spot. On the other hand, if there is no toxin present, what will happen is that your antibody will bind directly to the spot and you get a bright spot. So on the bottom left here, you can see that we've done this for microcystins and cylindrospermopsins. The panel, however, can be expanded very easily. On the right side, this is an example of where we've measured 5 different toxins simultaneously. Here are some representative standard curves for what we typically get out of these systems. The idea here is that, as you can see, we can provide a very similar quantitative range and quantitative outputs, very similar to what you would get out of an ELISA test. On the other hand, the workflow is much more like what you would get out of a rapid strip test. It's simply add the sample and go away for 10 minutes and then get the results. I also want to note that this is our Gen 2 test, which has improved congener coverage over our Gen 1 test. We want to extend this to a number of different areas in the future, and we're working on that very actively. First of all, the data I just showed you, that is more designed to be testing toxins around drinking water regulations. However, for recreational water, you can still use the same test that we're currently selling. The idea there is that you just do a simple dilution of your sample, and then you can get the results in the right range. That being said, we recognize that doing that dilution step is not ideal for everybody, so we would like to reformulate our assays to make them less sensitive so that you can immediately detect that recreational water. In addition, we're working on expanding the panel. Right now, we are working and funded to work on adding two different toxins to our freshwater panel. One of those toxins is paralytic shellfish poisoning, or also known as saxitoxins, and the other one is anatoxin A. We're also working on a program to do algal species detection and quantification. We also are working on a triplex test for detecting toxins in both shellfish and seawater. That is for saxitoxins, or paralytic shellfish toxins, domoic acid, and okadaic acid. And finally, we're also working on a program for Legionella detection. Legionella causes Legionnaire's disease. So to conclude, we have a fully developed low-cost test right now for the detection of both microcystins and cylindrospermopsins. We can go from bloom to a sample detection in about 10 minutes or 20 minutes with some cell lysis included. We're also working on some future menu expansion opportunities. Finally, I want to conclude by thanking all of the people who made this work possible. We've been very lucky in getting funding from a number of different agencies who've really supported this work. And in addition, we've got wonderful collaborators who've been absolutely essential to getting this work done. Thank you so much for your time and attention today.